Okay, so with that I want to introduce to you the idea of code kata. Who here has heard of this? Katas for code? One person, that's a good start. Code katas are exercises that you can do in code. But this kata is special for TDD purposes. If you want to learn how to do TDD, most of it is about muscle memory. Okay? It's really easy to learn the theory, but if you want to learn TDD for real, you have to exercise with it. You have to do it. One of the katas that I would recommend is a simple one called a string calculator. If you go to osherove.com//kata, you might see this description over here. And the idea of the kata is to create a simple calculator class. It has one method that only takes one parameter, and it's a string. And that string can contain 0 or more numbers, divided with a comma. And it returns the sum of all the numbers that it finds. That's the whole idea. As you progress through the exercises, it gets more and more complicated. So more and more demands on what needs to happen, more features requested. You should think about this as a project that every day you get a new feature that you never thought of. So try not to read ahead if you ever do the kata. We will later take 30 minutes and try to do it ourselves as pairs, so you can feel what it's like. It's a good way to practice TDD because it's not very complicated. It's more about learning through your fingers how to do something. In the page itself, you can see a lot of videos on how other people exercise the kata in basically all of the recent languages. So Java, Ruby, C#, Erlang, Scheme, Haskell, a couple of them in Perl, in PHP. So, and there is one in JavaScript actually. So you can see how it's done in JavaScript as well. And what I'm going to do is I'm going to show you the first steps of the kata right now, so you can see the TDD process, although you already know some of it. And after that, you're going to try it yourselves. So I'm going to assume that every 2 people here will have at least one laptop, because the exercise is done in pairs. So the first thing we do when we start the kata is we start with a blank solution. Now, if this was my 3 or 5 day TDD course, I would actually tell people, disconnect your mouse from your machines and try to do the whole thing without a mouse, just for the added difficulty, just to make it a bit more fun. But for now, don't worry about it. So, if I create a new solution, oh, that's not a new website, I just want a new solution. And I choose other project types, empty solution, blank solution. I call it kata. And in the kata, I add a new project class library. I'm going to call it kata.tests, because we don't have any integration tests here. Now, because it's TDD, we start with test first. So the first requirement in the kata is create a simple string calculator with this method. It can return 0 or more. It can return 0 for an empty string, or the sum of numbers if there are any numbers in the string. So I'm starting with the tests. So first thing I'm going to do is I'm going to rename this into string calculator tests, because that's the name of my class. I'm also going to set the package manager. So I'm gonna save time later by investing a little time right now. Package. I'm gonna look for package manager console, and I'm gonna give it a shortcut, Alt-N. It's not taken. I'm just gonna assign it. From now on, whenever I need to install something, I just press Alt-N, install package, and unit. So that will save me some of the work later. Now I have all the references. I'm going to remove 2 of these, and because I don't need them, and maybe this one. No.
Are you looking for?
Oh, I'm in the English one. That's why. Okay. Test fixture. Start with a test. The first test, and this is sometimes we face this dilemma. We could write a lot of different tests for this method. So which one should we write first? So the answer is, if we want to work in an incremental fashion, which is usually what we want to do, we start with the simplest test that will drive us to create something in the simplest way. So if we have a set of demands, such as it can return 0 for an empty string, it can return a number for a single number, we can send it 2 numbers or 15 numbers, which one of them is the simplest requirement to implement? What do you think? Empty string. It just feels simpler, right? Sometimes you don't know, but it feels like this is the smallest thing. It's also incrementally the beginning of a feature. You can start with numbers, but you might forget to do an empty string later. So we could start with add empty string, because add is the name of the method. And the expected behavior is returns 0. So for add, it returns 0 for an empty string. So now we can create the class. Remember, the class in this case doesn't exist yet, not just a method. So I might say string calculator, which doesn't exist yet. And I'm not going to make it compile until I finish the whole test. sc equals new string calculator. I'm not going to refactor this because I don't have 2 tests that use the constructor yet. The point here with TDD is to drive new functionality. So I don't worry about refactoring the test yet until I have 2 passing tests. sc.add empty string. Okay. Introduce a variable, int result, and assert. Now, there are 2 types of syntaxes for NUnit, which I only showed you one of them. You can do assert.requal, but there's also assert that result, comma, is, and then we have multiple things, equal to 0. So some people like this syntax better. It's your choice, as long as you're consistent. I personally like the first one, but a lot of people like this one. To me, this is less readable than just assert.requal. But it's just a choice. You should know that this exists. So I'm going to do assert. You know what? Let's just keep it this way. So now if I'm happy with the test, I'm going to make it compile, and I'm going to see it fail. To make it compile, I'm not even going to create the separate project. I'm just going to create it right here beneath my test. Create a class, create a method. Now, the default of the variable names are not good, so I'm just going to change them to be more readable numbers. Should I keep this or not? What do you think?
Exception or what?
Yeah, throw new not implemented exception. Some people like to keep this so they can see the test fail. I personally like to see the test fail on something that feels like the real system. So I'm actually going to return a bad value on purpose. Return -1. It just feels better to me. I don't have a good explanation why this makes more sense. Both of these will work. But this is closer to the solution that we need. This feels more like a bug that I would want to fix. Maybe that's my explanation. So now that I have this, I can go and for just once, right-click and run the test in this project. And of course it fails, and that's awesome. And now I get to fix it. in the simplest way possible. Remember, laziest developer in the world has to go home in 2 minutes. What do? They just make as many assumptions as possible. The assumption I can make here is I'm always going to get an empty string, because no one can prove otherwise yet. So I can just always return 0. And again, this is something that feels not intuitive, but the practice of simplicity is something that at the beginning you need to learn how to do, to simplify your actions. Right now, all this does is it proves to us that we're missing more tests, because we're not happy with this code. So what we're going to do, since this code is now read-only, you have to write another test. So I'm going to write another test, and this time it's still the add method. The scenario is going to be something that will drive me to remove this assumption that it's always empty. Okay? So what scenario should I choose? What do you think? Send in a? Send in 1? The number 1 or one number?
1 and 3.
1 in the string, okay. Just the number 1?
Or any number.
Yeah, but which number? 1. Just one number that is 1? Never mind. Okay, the scenario. So how would you explain it? A single number. Okay? Any number, right? A single number. A single number is simpler to prove than 2 numbers. So add with a single number, what should it do? Returns that number. Okay? So now I can say string calculator, and I can already feel that I would need to refactor, but only after this test passes. The point is to drive functionality that I can actually demo. Refactoring comes later. sc equals new string calculator. sc dot add. What is the number? 1 number of 1, right? Result. Int result assert are equal. We should expect. What should we expect? You sound very quiet. Assert that we get back 1 from result. Run all the tests. 1 passed, 1 failed. We can see the results here. Expected 1 but was 0. I just need to look at the test name to know. Okay, now we get to make everything right. The simplest thing possible to make all the tests pass. What do you think I should do now?
Turn 1.
Return 1. If I return 1, it will break the first test, so I can't do that. Make all the tests pass in the simplest way possible.
Return numbers.
Return numbers, but it's a string. It's supposed to be an int. I'm supposed to return an int.
Parse.
Parse. int.parse. Numbers. Make sense? Int.parse will turn a string into a number. Okay? Okay, let's run all the tests. Weird. That's weird. Could we actually have a bug in one line of code? Okay. Ed, empty string, return 0, failed. Input string was not in the correct format, dude. Okay, so I guess we just discovered our first bug. So that was simple, but it doesn't work. So what do we have to do? What should we do? What do you think? Obviously it means that int.parse doesn't work with empty strings. Okay, so we need to make the simplest thing, but still pass all the tests. So that doesn't work. Try parse. Try parse is an if. It's the same thing. Try parse, most people don't know it, so I'm going to use a different way. If numbers length is 0, just return 0. Okay, otherwise, what should I do? You know what I'm going to do, right?
Parse it.
Parse it?
Return
Can I
one.
make an assumption here?
Return 1.
I can make an assumption. If it's not an empty string, it's always 1. Horrible, horrible. 2 passed. Unfortunately, I can't change this now. So, if you wanted me to fix this, we're going to have another test. But before we do that, let's make the test a bit more maintainable. So I'm going to extract this into a factoring method. Make calc. Same thing here. Run all the tests again to make sure I didn't break anything. That's why I want all the tests to be passing. So if I change the test and something breaks, I know that it's because of my change. If I refactor the test while something is breaking, I won't know if it's breaking because of my changes or it's breaking because it always breaks. So I want to always have a clean sheet of knowledge. Okay. So we have concluded this is not great. I'm assuming that you're not happy with this code. So what we're going to do is we're going to prove that we cannot make an assumption that the number is always 1. To do that, we can just go here and turn this into a test case. So for example, I'm going to make this into a parameter. Control-Alt-P. This is the numbers. Control-Alt-P. This is the expected. Go to test case. Send in 1. Expect 1. Just run all the tests again. Okay, 2 passed. Duplicate with Control-D. What number should I send in? 2. Perfect. Run all the tests. Gotcha. Okay. Expected 2, but was 1. Okay, I guess I can't hide anymore with my assumptions that it's always 1. So what should I do? What's the simplest way to make all the tests pass? Someone once suggested you just do an if. If it's a 1, you return 1. If it's a 2, you return 2. But that's not as simple as just int.parse. It's not as simple. So what's the difference? Simple is shorter. Simple is less indentation. If I need to do an if, I have more indentation, right? So visually, I can actually say that something is simpler than something else if it's more to the left than the other thing, for example. If it's closer to the beginning of the method, it's simpler than if it's the bottom of the method. But in this case, this might be everything I need in .parse. Sometimes the actual solution is the solution. Okay? But it took us 3 tries to get here. So parse numbers. Run all the tests. 3 passed. Now, several interesting things here. First of all, if my manager comes in and says, got a demo for me, I can actually tell them, look, it's partially working. It's working for an empty string, and it's working for single numbers. It's actually partially working. It's incremental development. It doesn't work with multiple numbers yet, but it will. So if I can say that something works now, 10 minutes after, it means that if I chose to release today, I would have a partial release. If I'm working in iterations of 2 weeks, and I'm working in micro iterations like this, of every few minutes, it means that every 2 weeks, the release day is just another day. Because every day, every hour, we have something we had that we didn't have an hour before. Because it's always working. That's a big difference from working on something for 3 days, and it's not working at all, then suddenly it works. Right? And you're always in the 95% working. Oh, it's almost working, I'm at 95%. Just another 90% to go. Okay? So you should never feel like that again. If you work in an incremental way, you always have something to return. The simplicity goes toward that feeling. Okay, so I guess that's working. But you know what? Maybe I can make another assumption that I didn't consider. For example, and this is one thing that sometimes I force myself to do, although I don't expect you to remember to do it on your own. Sometimes it works to remember it, sometimes it doesn't. I can make an assumption about the length of the number if I wanted to. I can say the numbers are always one character, right? So I can parse the numbers, just the first character. I don't care about anything else. The string. All the tests will still pass, although I added code to make this happen. However, if I do this, it forces me to write another test that says numbers can be more than one character. If I don't do this, I don't even consider writing that test. A lot of times we don't think about tests that seem obvious. But for now, this is just a thinking point. Here's another thing you can do. Test with ncover. So ncover is a free tool. This is an older version. It's a free tool that tells you the coverage details of something. Right now we have 100% code coverage, okay, in our tests and in our code. If you work in that incremental way, in the simplest way possible, then every piece of code that you do has a reason to exist because a test expected it. So that every piece of code is covered. So you should expect 95 to 100% code coverage if you do the things this way. Having said that, high code coverage doesn't mean anything. Okay? If I tell you that I have 100% code coverage, or if you tell me we have 100% code coverage, that doesn't mean anything to me, because maybe all your tests don't even have asserts. Okay? So code coverage doesn't mean that you have quality. It just means that you have code coverage. However, low code coverage, 20% code coverage means something. What does it mean? If we have 20% code coverage, what does it mean?
You don't have a lot of tests.
We're missing tests. That's all it means. 100% doesn't mean anything. It only means something if you do test reviews. If you look at each other's tests and you review them to make sure that the tests are good. If I know that your tests are good, then 100% means something. But if I don't know that your tests are good, then 100% is meaningless. So as a goal, if you ever had a goal to strive for coverage, it should be to strive for coverage plus test reviews. Okay? Because when you only have the goal of coverage, then as developers, we are only aimed at just having a test that does something. We're not aimed at the quality. If we have test coverage, then the test will be good and the coverage will mean something. So I can go on with this. For example, I can say, okay, what if I give you more than a single number? Because right now, you assume that you can parse the number. But if I have two numbers, I'm pretty sure you can't parse that, because there's a comma in between them. So add with multiple numbers. Why didn't I just add it to the previous one? What do you think? Think about that for a second. We'll talk about that in a second as well. Multiple numbers. Sums them up. The difference is in the scenario then. Okay? So if someone reads multiple test cases, the serial letter, and they see 1, 2, and then suddenly like weird stuff, there is no explanation why that weird stuff exists in those parameters. The name of the test should explain generically everything that the test cases above it do. If it doesn't, for example, it says single number, but I have some inputs with multiple numbers, it doesn't make sense. So either I change the scenario, but I don't want to change it, because this is a specific feature to handle a single number. It's a different feature to handle multiple numbers, because I'm working incrementally. So now I can say make calc, exact variable, and that should be sc add, and again the simplest numbers would be 1 and 2, int result, assert are equal, so we're expecting 3 from result. Run all the tests. This time it's going to run with coverage because that's the last action that I did. You can see 86% because something failed. Okay, I'm going to run them without coverage now. It says input string was not in correct format, just for multiple numbers. So now I have to do the simplest thing that could possibly work and make all the tests pass. Any ideas?
Split the string.
Split the string.
Commas.
Yeah, okay. So, but then will it know how to handle a single number? If I split the string?
No.
Okay. So here's what I want you guys to do. Split into pairs. 2 people on one machine. You switch. Every time one person writes a test, the other person solves the test. Okay, one person is lazy, the other is not. And then you switch the next time. Try to do the kata on your own. Get all the way to this situation. Try to solve it on your own in the simplest way possible. Okay? If you're working in JavaScript, do it in JavaScript. There's a framework called Jasmine, which I recommend. I'm not a JavaScript developer yet, so I'm not going to be able to help you, but setting up the environment might be a good learning opportunity for you anyway. Okay? If you're doing in .NET, do the things that I did in .NET. Any questions before we get started? Okay, so let's take 30 minutes and see where we get in 30 minutes. And I'll just run around and look at how you write code and give you various tips and tricks. Okay? Good luck. Let's be careful out there. So if you don't remember the URL, it's